Hi everyone, it's Mrs. Bebo. In this video, this is going to be the last one about absolute value equations, and we're going to take a look still at some problems where we have to write the equation given the graph like you see on the screen here, as well as some special types of absolute value equations where we have some work we have to do first before we can actually solve them. So let's take a look at what we have on the screen right now. So for both of these, we're going to write an equation involving absolute value for the graph. This should look familiar to the end of the part 2 to this video series. So in the last video, I had given us this general rule, and all of this is great, minus this last piece of advice here, because of when we have these values that are going into the negatives, right, these solutions that are in the negatives, we can't just add these together and divide it by 2 to find the midpoint. So we have to actually go through and think about how far each of those values are away from 0 and kind of go from there. So if they don't give you a number line, then you would want to sketch it out, or again, just keep in mind, you have to be careful with the fact that one of these values, or in some cases, both of them are negative, and so this really does not apply to the situations we're seeing on the screen here. It worked great when the solutions were both positive, right? Those endpoints were positive. In this case, not so much. So if I take a look at my graph here, we have, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're 10 spaces apart. So 1, 2, 3, 4, 5. So this is going to be my midpoint here, right? So -2 is going to be my midpoint now that I've gotten that counted out. And then we can see that the two endpoints, they are 5 spaces or 5 units away from the midpoint. And then now that we have that information, we can still set it up with using our general rule. We just can't necessarily use this calculation, this trick that I had here for finding the midpoint. So that's why we had to go through and just kind of visualize it and count it out on the graph. So we got -2 as our midpoint. So when I write out my absolute value equation, we have the absolute value of x minus -2, because my midpoint was a -2, right? So that's all in absolute value symbols, and then that's going to equal that distance, so in this case 5, and we just have to clean it up. We don't want this to say subtracting a -2, so my equation is actually going to be x plus 2, and then that equals 5. And then that would be it that we need to do for that one. So we're going to try the same thing on the next one. So write an equation involving absolute value for the graph. So again, we need to calculate that midpoint, or find that midpoint, which this one hopefully is pretty quick to see. That -3 is in the middle there. And this means our endpoints are 2 units away from the midpoint. And so when I set up my equation, we are going to have x minus my midpoint, so x minus -3. Again, that's inside the absolute value symbols. And this is going to equal that distance away from the endpoint to the midpoint. And so we clean this up. This is going to be x plus 3, and then equals 2. So there's a couple of examples of what happens when we have our solutions. Either one of them's in the negatives, or maybe both of them are in the negatives, how we actually set up that absolute value equation. All right, so some other situations that might pop up when working with absolute value equations are something like this, where we have to solve each equation, and we're going to graph the solution set. But notice that my absolute value symbol, there's more going on, right? It's not just a set of absolute value symbols equals this number here. So we actually have to go through and isolate this grouping symbol, right, these absolute value symbols, away from everything else. So treating this as if it's like a 2-step equation, right, we're going to go through and we're going to add 5 to both sides. We end up with 2 absolute value of A equals 18. And then our last step is to divide both sides by 2. And what happens is we get the absolute value of A equals 9. Well, in this situation, right, we know that A is going to equal 9, or A could be equal to -9, because absolute value, again, is talking about a distance. So if I take the absolute value of +9, I get 9, and if I take the absolute value of -9, also gives me 9. So if we see something like this, whenever we're working with absolute value equations, right, you just have to go through and isolate this piece here, this absolute value of A, by doing your inverse operations. And once you have it alone, then we just solve it by, again, taking into consideration the 2 cases, the positive and the negative. So let's try it on this last example for this video. We have 4 minus 2 multiplied by the absolute value of n equals 12. So just like before, we need to use inverse operations to solve this. We need to get rid of this +4. So to do that, we're going to subtract 4 from both sides. We'll have -2 absolute value of n equals 12 minus 4, which is 8. And then our next and final step before breaking this into its 2 parts is to divide by -2. And we end up with the absolute value of n is equal to -4. Well, the problem here though, we can't even break this into 2 because this isn't possible, right? The distance, the absolute value is always going to be positive. So this actually ends up being a null set situation. Okay, so that is it for some additional examples involving absolute value equations. Thank you again for watching.